Hey everyone, welcome back to Cracking the GRE Math Subject Tests, Linear Algebra. Now we're on question number 16. This question is, I'd say, about a medium difficulty. We're given two linear operators, s and t, and we're told that s rotates each vector 90 degrees counterclockwise and t reflects each vector through the y-axis. And then we're asked about the composition of s and t, and of t and s, and we need to know which of these options holds true, that the composition of s and t is equal to I or negative I, or that the composition of t with s is equal to I, or that their compositions are equal to each other regardless of which order you compose in, or that they're the negatives of each other. Okay, well, I think the easiest way to approach this problem is to draw a picture. Let's draw ST, and then later we'll see what happens with TS. So what I'll do is I'll take the unit vector and say this is x and y. So let's take the unit vector here, let's call it v1, and the unit vector in the y direction, let's call that v2. And let's see what ST does to each of them. Well, remember, when you're composing, first you have to perform T. You go from right to left. First perform T and then perform S. So T is a reflection through the y-axis. So if we reflect V1 through the y-axis, it'll end up over here. Okay. And then we have to rotate 90 degrees counterclockwise. That's what S does. So we're going to end up with the image of V1 over here. Let's call that V1 prime. Now for V2, a reflection through the y-axis isn't going to change anything. That's just going to stay the same. So it's going to be here. And then a counterclockwise rotation of 90 degrees, that's going to bring us over here. Right, counterclockwise. So this is going to be V2 prime. Alright, now let's see what TS does. We'll start out with our same unit vectors, V1 and V2. Now S rotates 90 degrees counterclockwise. So let's see, with V1, we're going to end up over here. And then T reflects in the y-axis. Well, the reflection in the y-axis is just going to give us the same thing. That's not going to change anything. So this is going to be V1 prime. Now V2, we're going to rotate it 90 degrees counterclockwise. That's going to be here. And then we're going to reflect it along the y-axis. So that's going to bring us into the positive x direction. So that's V2 prime. Alright, so what can we say about this? Well, is ST the identity? That's the first option. No, it's not, because V1 got mapped somewhere else and V2 got mapped somewhere else. Same thing with it's also not in the negative of the identity. It doesn't. V1 didn't get mapped to its negative. Neither did V2. And TS, that's also not the identity, because V1 and V2 kind of switch places. And ST and TS, they're not equal to each other, because V1 prime and V2 prime ended up in different places. Well, then this is the only option that's left. So I'm guessing that it's true, but let's just make sure. Is ST the negative of TS? Well, let's see. V1 prime over here that's like 0, negative 1. And here it's 0, positive 1. So that works. And then V2 prime here is negative 1, 0. And V2 prime here is positive 1, 0. So, yeah, they are negatives of each other. So the answer is E.